Hello students, let us solve one HOTS question based on the topic Pythagoras Theorem from class 10. Question is, in an isosceles triangle, length of congruent sides is 13 centimeter and its base is 10 centimeter. Find the distance between the vertex opposite to the base and the centroid. So to solve this problem, we need a diagram. So let's draw. One triangle is given which is isosceles triangle. So let us name this triangle as triangle PQR. As it is isosceles triangle, any two sides of this must be congruent. So let us consider triangle PQR, which is an isosceles triangle. Here, let us consider PQ is congruent with PR and the length of congruent sides is given to be 13. That's why PQ is equal to PR is equal to 13 centimeter. And it is given that the base is 10 centimeter. So for this triangle PQR, QR is the base. That's why the length of this base QR is 10 centimeter. Now the question is asked to find the distance between the vertex opposite to the base and the centroid. Now for this triangle, base is QR and the vertex opposite to it is P. So we have to find the distance between point P and a centroid of this triangle. So for that we must have the centroid of this triangle. So to have the centroid of a triangle, first of all we should have a median. So before that we'll do one construction. We'll draw segment which is perpendicular to base QR from point P. We'll name this as segment PS. So here we have constructed segment PS is perpendicular to segment QR. Now as we have drawn one perpendicular from point P, we have got two right angle triangles, triangle PSQ and triangle PSR. We are trying to show that these two triangles are congruent. So for these two triangles, we have segment PQ is congruent to segment PR because it is given as it is isosceles triangle and it is given that PQ is equal to PR is equal to 13. That's why these two segments are congruent. Then we have segment PS is congruent to segment PS as it is a common side for both of these two triangles. Segment PS is congruent to segment PS as a common side. If we see in the diagram, for these two triangles, PQ and PR are the hypotenuse and PS is one side of these triangles. That's why these two triangles must be congruent by hypotenuse side theorem. That is, triangle PSQ is congruent to triangle PSR by hypotenuse side theorem. And we know that if two triangles are congruent, then their corresponding sides are also congruent. So here, the corresponding side of QS is SR, so they must be congruent. This segment QS is congruent to segment SR as corresponding sides of congruent triangles. Now the length of QR is given as it is a base is given to be 10. That's why QR is equal to 10. Now we have QS is congruent to SR. That means QS must be equal to SR, which must be equal to half of QR. And the length of QR is 10 centimeter. So we'll replace here QR by 10 just to get QS is equal to SR is equal to half into 10. Now if we divide 10 by 2, we get 5. This QS is equal to SR is equal to 5. Here the length of QS and SR is 5. Now consider triangle PSQ, which is a right angle triangle, and in that we can use Pythagoras theorem. So by that we have a hypotenuse square is equal to side 1 square plus side 2 square. So hypotenuse over here is PQ. That's why we can write PQ square is equal to remaining two sides are PS and QS. That's why we have PS square plus QS square. Length of PQ is given to be 13. So we'll replace here PQ by 13 square is equal to PS we have to find it. So we'll take PS square as it is plus QS we have just found to be 5. We'll replace QS square by 5 square. So 13 square is 169 is equal to PS square as it is plus 5 square is 25. If you take 25 to the left hand side, it will become minus. Is 169 minus 25 is equal to PS square. 169 minus 25, that's 144, that is equal to PS square. If you take square root on both the sides, the square root of 144 is 12 and square root of PS square is PS. So 12 is equal to PS, that is the length of segment PS is 12. As we can see in the diagram, the length of segment PS is 12. Now the next step would be S is the midpoint of segment QR, as we have just proved that QS is congruent to SR. That means so the S must be the midpoint of segment QR, and if S is the midpoint of segment QR, segment PS must be the median, because we know that segment joining a vertex of a triangle and midpoint of its opposite side is called as a median. So here in this case segment PS is the median. Now here in the question we have to find distance between vertex opposite to the base and the centroid. Now we have to get the centroid for this triangle. We know that for any triangle, centroid is point of intersection of three medians. So as PS is a median, on segment PS there must be any point which is point G, which must be the centroid of triangle PQR. So let us consider here point G, which is centroid of triangle PQR. And also we know one property of a centroid of a triangle, that is centroid of a triangle divides each median in the ratio 2:1. Now as G is the centroid and PS is a median, point G must divide segment PS in the ratio 2:1. That means PG must be 2/3 of segment PS. So PG is equal to 2/3 into PS. Now we have found the length of segment PS earlier. That is the length of segment PS is 12. That's why we'll replace here PS by 12 to get PG is equal to 2/3 into 12. Now if we divide 12 by 3, we get 3 4s are 12. 4 into 2, that's 8. We'll get the length of segment PG as 8 centimeter. As we can see here, segment PG is nothing but the segment joining the vertex opposite to side QR, that is point P, and the centroid of a triangle, that is point G. So we have found here the length of segment PG, that is we have found distance between the vertex opposite to the base and the centroid of this triangle, that is PG is equal to 8 centimeter. This is the answer of the question. The distance between the vertex opposite to the base and the centroid is 8 centimeter.